Hi guys, I would like to talk to you about the classification of systems. And when we talk about classification of systems, we will be talking about linearity. Okay, is this system linear or non-linear? Okay, and then the second one that we will be talking about will be like, is this system time invariant, or time variant, or time varying? Okay, and then we will be talking about static systems or dynamic systems. Dynamic systems. We may also talk about causal or non-causal systems. We will be also talking about invertible systems or non-invertible systems. Okay. And then finally, we will be talking about stable systems or unstable systems. So here are some of the things that we will be mainly focusing on. Okay, so if we talk about linearity, we will be focusing on linearity, time invariance, causality, and stability most of the time. Okay, so these are the four things that we will be focusing on in this part of the class or the subcomponents. Okay, when we think about linearity or non-linearity, if you remember, we should start with linearity here. Okay, and then if we talk about linearity, we said this to you, right? If you remember, I have one x1 of t and I have one system and my output is y of y1 of t, and I have another input to my same system and I will obtain y2 of t. Okay, so if my system is linear, I should be able to write a times x1 of t times b1 x2 of t. If this is my input to my system, my output should be a y1 of t plus b y2 of t. Okay, so if this happens with your system, then this is a linear system. Let's check on one example if this is the case. For example, if I tell you that my system characteristic is given like this, y of t is equal to x squared t. And my question is this a linear system? Okay, this is my question. And I want you to think about this at this point and then come up with any questions, any answers for that. Arkadaşlar, if you want to solve this question, so what I'm saying is, when I talk about these properties, linearity, time invariance, causality, or stability, you need to prove that if a system is linear or not, or causal or not, okay? I will give you for each property some examples that you will be able to prove that if a system is linear or not, okay? So how can we prove that? So my system is, it takes my x1 of t as the input and then obtains x1 of t square as the output, okay? If I give a x1 of t, then I will have this a x1 of t square, right? So if this is my input and my system is a squaring system, that will be the case. So if my input is b x1 of t, and if I give this to my system, what will be the output? b x2, sorry, this should be x2 of t, and I should be taking the square of this. Okay, so if I add these two, my output should be like that. Okay, so this is how we start the proof. Okay, my output here will be a square x1 of t plus b square x2 of t will be my my output. Okay, so how about if this is how you prove these kind of problems. Okay arkadaşlar, we apply this separately, and then if my input is like this, ax1 plus bx2 of t, this is my input. Okay, this is my input, and if I give this to my system, what is my output? Okay, and I will check if this is equal to this situation. Okay, then what will be the output? I will take this input, and then the output will be the square of this whole input, right? So what is the output here? A square x1 square t plus b square x2 square t plus 2ab x1 of t times x2 of t, right? So are these two things equal to each other? So is this equal to this whole thing? No, right? So especially this part is different here. So that means this system is not linear, which is non-linear. Okay, squaring, if a system requires squaring, that means it is not a linear system. It is a non-linear system. Okay, how did I solve this question? I said if I apply inputs separately, I will obtain an output like that. If I apply them together and check if the outputs are the same, then I will check this one and this one. If they are equal, then I would say this is a linear system. Otherwise, it's not linear. Okay, let me give you one linear example. For example, y of t is equal to 2x of t plus 1. Okay, so if this is my system, this is called system equation. Okay, system equation. And this describes how the input is related with the output. Okay, we will have these kind of, if you remember from differential equations or circuit theory, we might have voltage as my output, and we might have current as my input, for example, or voltage applied as an input, and the output might be the voltage across the capacitor. Okay, like we had these kind of things. For example, this was my input and this was my output, and we might have relationship between these two things, and then we should check if the system is linear or not. Okay, when you think about that, what would you see? If I have a x1 of t as my input, my output would be 2a x1 of t plus 1, right? So let me erase this part. So if my output is b x2 of t, and I give it to my system as my input, 2b x2 of t plus 1, okay? If I add these two, 2a x1 of t plus b x2 of t plus 2, right? Or we might say, instead of this, we might say this, right? So I may add 1 here and then close the parentheses and get rid of this one. So 2a, 2b plus 2, right? If I add these things right like that. So if I come back and say, if I add a x1 of t plus b x2 of t in my as my input, my y of t will be equal to 2 times a x1 of t plus b x2 of t, okay? And then this is my input right now, plus 1 is like that, okay? Arkadaşlar, you can see that when we multiply these, this will not be equal to this, right? There will be one extra. So this is like 2a, x1, 2b, x2, and 2 plus 2. This will be 2a, x1, 2b, x2 plus 1. So there will be a difference between these two. So this is again a nonlinear system, okay? For example, let me give you one more example and then move on. For example, my x of t is the integral or the derivative of the input, okay? If I give an input to my system, the system gives me the derivative of the input. Is this a linear system or not? For example, if we say a x1 of t enters my system, I would get a dx1 of t dt. If I have b x2 of t as my input, it will be b dx2 of dt. Okay, if I add these two, a dx1 of t dt plus b dx2 of t dt. Okay, now I should check like a x1 of t plus b x2 of t is my input to my system, and y of t would be output, and I would check if these two are equal to each other. If I do this, if I take this as my input, I would take the derivative of each component, a dx1 of t over dt plus b dx2 of t dt will be equal to y of t. And you see these two are equal to each other. That means the system is linear, okay? This is all for this linearity part. I will continue with time invariant systems, causal systems, and especially stable systems, okay, in the next videos.